Hey, and welcome back to the Building Apps for Windows Phone 8.1 Jumpstart. Right now, we're going to jump into talking about adapting our UI for different screens and orientations for our Windows Phone applications. And this actually is going to have some application across not just phones, but kind of bleeding into building UIs that live across multiple devices, phones and tablets. And
yeah, I mean the techniques we're talking about is just the same for Windows Phone as it is for Windows Phone 8.1. So we're going to be talking about fluid design things and techniques for laying out your XAML so it will adapt nicely and flow into different size displays.
Yep. So in this module, we're going to cover adapting that diverse range of screen sizes, different resolutions across a phone, across tablets. We're going to talk about what was the Windows Phone 8 Silverlight approach and how does that compare to what we're going to be doing with Windows XAML and Windows Phone 8. Then we're going to use the emulators to test some of those different screen sizes and resolutions, which is really great unless you want to, hoard about 30 different devices and test what it looks like on every single device. And then finally, we'll get into some of the nitty-gritty details of programming for different screen sizes and different resolutions. So the need for this adaptive UI is driven by the fact that we have an increasingly diverse set of Windows phones.
It's only going to get more diverse.
And it's only going to get more diverse. I personally use a Nokia 520, which is a nice little 4.0 something inch device, low screen resolution, but it cost me $60. On the other hand, I did not purchase, but was given to by Microsoft, this beautiful 1520, which is it's a monster. It's a huge phone, 6-inch screen size, and 1080p resolution. So
beautiful.
Right. So we've got. I mean, we could fit this one inside of that one if we wanted to. But we got applications that are going to be running on both of them, so we need to make sure that our applications do, in fact, run on both our smaller phones and our larger phones. In addition to that, they are going to be running on multiple orientations, especially when we're talking about applications that are dealing with photos and videos. The landscape mode is vital for the good application of those, or for good design of those applications. So the applications need to, all of our apps need to cope with this diverse set of display sizes, resolutions, and orientations.
And actually, you tend to use Visual Studio and you'll start it up and this designer is kind of the 4.5 inch and that's what most people are going to kind of end up thinking about, and you kind of get into this, you forget there's actually this diverse range of phones there. So
yeah. So to recap, this was a Windows Phone 8 design as of not too long ago. There is essentially an app was designed with one resolution in mind, and the OS applied all the vector scaling for that. And so you would design your phone application with your your sort of standard 4-inch, I think it was 480 by 800 resolution. And then as the phone resolution got bigger, we simply scaled that up. If it got a little longer, we just add a little space down at the bottom. But that meant that we were looking at the same application on a 4-inch device as we were on a 6-inch device.
Yeah, and but it was easy, good for a developer or designer.
Right, it was easier.
It's all the same.
Right,
it was 480 wide. They're all 480 wide.
Right,
800 or 853. So it's easy.
Right, but for the user, what you ended up with was, as you got to the larger size devices, you get an application that started to look a little comically large and like sort of a large print book on your phone. With the latest update of Windows Phone 8, the GDR3 update, we started to get a little bit of a hint of how we could use an expanded size and a larger screen to deliver better content to a user. And so we saw with the 1520 GDR3 update that we had this extra button, an extra row of tiles, so that we gave users with more screen real estate a better option for accessing all of their information, getting as many tiles and as much information on the screen at one time.
This is a kind of little bit of a side topic, isn't it? It's like
So this kind of the standard way to think about any device has been pixels. How many pixels does it have? But when it comes to phones, especially, this can be a little bit misleading. And part of this is because we have different screen sizes that are. We have many of the same screen sizes that support different resolutions. So, for example, the Lumia 1320 is a lower end, lower cost device, but it's exactly the same screen size as the 1520. So what we have is a 720p screen versus a 1020p screen that are exactly the same physical size. Now let's say that we had been designing with pixel sizes in mind. Let's say we've got a header maybe, and we've designed it for the 1320. Well, that makes it 720 pixels wide and maybe 100 pixels at the top. We bring it over to the 1020, now it's squished up at the top and it doesn't even take up all the space that we have on our phone. And so we have to stop thinking, we developers and designers have to stop thinking about, oh, well, pixel size equals this size, because we're looking at different DPI and different pixel size for the same screen size. Similarly, we have the idea of the raw device pixels. I'm sorry, another way we can that raw device pixels doesn't quite work is because we do have these super high DPI devices, the 1020p on a 6-inch device. Well, that's going to have a lot more pixels than an 8-inch device like the Dell Venue 8 Pro, which is...
So the real true dots per inch on that 1520 is like really high dots per inch.
Right.
The physically much bigger tablet has much less pixel density on it of true real pixels.
Exactly, but that doesn't mean. But we still wouldn't want a 6-inch display style moving over to an 8-inch display device. They're different devices with different sizes, and we're going to be using them differently. And so So what we need to deal with is, okay, we need to reuse pieces of the UI across platforms, and we need an abstraction that works for those high-resolution devices and smaller screens, and lower resolution devices with larger screens.
It's like you want to be able to cut and paste a block of XAML from one app and stick it onto an app that's going to run on a huge wall display or something,
Right.
and it will look right.
Right. So it's actually a big design question, and we're going to explain how we've designed the Windows XAML to kind of tackle that problem. And that's the Windows Phone 8.1 approach. How do we...
Well, although actually it's the Windows 8.1 approach, isn't it? Because it's obviously
Right.
the same one that's used for tablet and PC.
Yep, and
apps.
this is one of those universal concepts
Yep.
that now spans from phone to large phone to tablet to wall-sized devices. No longer do we have a set of devices. Instead, we have a screen of unknown size. It is upper bounds of X, Y, and it varies depending on the device. The maximum values of the X, Y are dependent on the device in question, and the display resolution of that device. So we've got this sort of infinite virtual canvas on which we are laying out all of our XAML elements. So we've got this thing called scale factor. And each device is going to have a scale factor, and that's calculated by taking how many actual pixels are on the device, dividing that by the physical width of the device, and then multiplying that by a platform constant. That scale factor is not going to be any smaller than 1, and it's going to get rounded up to the nearest 0.2. And the platform constant depends on the viewing distance of the device. Now, well, what does that mean? Okay, well, I've got a phone here, a small phone or a big phone. I'm probably holding it about 18 inches from my eyes. That makes the physical size of the device actually not as important as how I perceive the size at 18 inches from my face. I have a Surface tablet here. It's a 10-inch device, but I'm going to hold it a little bit further away, maybe 2 feet, maybe 30 inches away from my face. And then behind us, we have a big screen. I'm going to guess maybe about 36, 40-inch screen there. But I'm never going to be standing 2 feet away from the screen and looking at it. I'm always going to be further away. And so the platform constant is a device-by-device constant that helps give us the appropriate scale factor depending on how far away from that specific device
the typical usage of it.
we're going to be using it. Yep.
Yeah.
So we take the raw pixels that we have on the device, We divide it by that scale factor that we're given, and then we get the real key, which is the view pixels on that device. And all of our design is going to be done inside with this concept of view pixels in mind.
Yeah. You don't have to do any of this calculation yourself, just in case.
Right.
This is for interest, so you can figure out how it's working.
Right.
Yeah, but the view pixels actually gives you a reasonable XY coordinate layout system that works and will work for the device, any device.
Right, and the goal here is to kind of abstract all of this work away from a developer. Don't worry about the resolution of your device. Don't worry which device it's on or how far away it is. All you need to worry about is this view pixel rendering, because all of the pixel information that you give your UI is going to be translated into this view pixel information. So this helps us when we're dealing with images that are the same size but higher resolution. So we could have a lower resolution 5.5-inch device or a super high resolution 5.5-inch device. That doesn't matter. It's a 5.5-inch device. It is 800 by 450 view pixels. Similarly, we could have the same resolution on larger size devices. We could have a super high DPI 1080p screen that's only 4.7 inches. Well, it's actually going to be smaller view pixels, because just because it's higher DPI doesn't mean you're holding it closer to your face. The larger screens get more view pixels because from a user perspective, it's a bigger size.
I think, for me, to summarize this, the view pixels you end up working with, it's just based on ends up being based on the physical size of the device.
Right.
And whether it's a phone or a tablet or a TV,
right.
So, but it gives you the right outcome for doing design that's just going to work based on the physical size of the device. Yeah,
there's a little bit of secret sauce in there, but ultimately the goal is we're giving you the right pixel size for the usage scenario: phone, tablet, large screen. So when we're working with this practically, the emulator is going to be our best friend. We felt this is so important that we've actually designed emulators not just with resolution sizes, but we've also imprinted these physical sizes onto all the emulators. So you can see that you can run specifically a 4-inch emulator, or you can run specifically a 6-inch emulator, and so you can do your design and do your testing on these different screen sizes.
And not only that, but different physically sized emulators at different screen resolutions.
Right.
Yeah.
Right.
So you've got the whole works there.
So how does the right app? How does an app provide that right UI experience on a given device? First of all, we need to make sure that our bitmap images are working with the scaling system. We want to make sure that we have the right high resolution content for the right high resolution devices. We need to build a responsive UI that adapts to that usable screen size. We want a UI that's going to give more space where it has more space, and is going to maybe even hide elements where there's not enough room to show them. And then last, when we're doing our real fine-tuning work, we can make use of the display information class for that granular display info. We can actually go in and we can query what's my raw pixels look like, and what are the view pixels that we have on this particular device.
It's fairly few cases where you're going to want to do that.
Right, exactly. This is that's something where maybe we're looking to download some web images and we can't rely on the responsive image system that we have built into the application. In that case, then maybe display information will help give us more a better idea of how to respond. So let's start with getting those just the right bitmaps that we need for our low DPI and high DPI phones. Because bitmaps only scale so far, right? You have a 100 by 100 bitmap, and if you scale it up to 300 by 300 or 400 by 400, it's just going to start to look kind of bad. And so we have a system for resolving resources. If we set the image to a particular source, the system attempts to find that image name along with a scale dash number. And the value of that number is based on the scale factor that we were talking about earlier. If it doesn't find an exact match, it's going to fall back to the next best scale factor. So let's see what this looks like in a little bit of a conceptual example. We have our image, we've set our source. It's loaded onto a phone where the scale factor is 3.2, which is actually really high DPI, probably. The system has defined the scale factor buckets. And so there's a scale factor at 100 and 120 and 140, 200, 300, 400. This scale factor of 3.2 falls into one of these buckets, right in there between 300 and 400. We're going to round up and pick the 400 element, and that high resolution image is the one that we're going to bring in. We're going to place wherever that image control has gone. So if you're a designer or you're a developer and you're creating these images, you need to make, there are two kinds of images you're going to create. The first is the variable size image, something that you're going to put in the background, for example, in that pivot application, or the hub application that we saw in the last session. That's going to resize to fit the full screen of the device, and so we need to design it for a high resolution image, or a high resolution display. When it's on a low resolution display, don't worry, the system will take that, it'll resize it, it'll put it in just the way it needs to be. When we're looking at fixed size images, we want to start by designing it for a 140 scale device or a 1.4 scale device. If we open up our design area and we size at 100% to get our baseline width and height, we can take that number, in this case 100 pixels by 100 pixels, and we can scale it up to other images. The two image sizes we want to keep in mind are the 140 scale and then the 240 scale. That's the baseline. That's the absolute essentials that you need. Although if you want the best experience for the most devices, then try to scale it up at a number of those gradations.
Yeah. But at the very least, you want to just try and supply a whole set of high-res 240 scale images, and they'll be scaled down just fine for the lower ones, but obviously at a slight cost of resources. Yeah.
So let's take a look at what that means in some sort of practical application. This is actually very cool because it shows off the tools that we have and how powerful they are for doing things like managing these different resolutions. This is a really complicated application. It is a grid with another grid and an image inside. And the image is set to this resolution.png. And if we open up our images, you see we have these different folders: scale 1, scale-100, scale-140, -180. If we hover over those, we can see these are actually different images that give us an idea of what's going on. So they have the scale imprinted on them so that when we load them into our device, we can actually see what scale we're working with. I could load up multiple emulators and cripple my system, or I'm actually going to use the device tab over here. And you see what we're looking at right now is a 480 by 800 display type. We can change that to it's not quite 720, but a higher resolution. And you see it's pulled. We are looking at the exact same image source, but because it's a higher resolution, the system goes, it knows which image to find, it finds that image, it pulls it back.
But the real clever thing about this is in the XAML, you don't have to specifically load in that image. You just leave the scale bit out of the path and it works it out and it will go and find it. As long as you use this convention for naming of the folder path.
Exactly.
And there's another way you can do it just by embedding it in the name as well. So, but
yep.
Either way, the system will just pick the right one for you.
Yep.
And you don't have to actually specifically write any code to say, oh, what resolution are we on? Go and load this one. Oh, no, we're on the different one. Go and load this one. So,
yep. Yeah. And the other one, and it can be a little bit hard to show sometimes on the emulator because the emulator is has a percentage here. But if we go to 180, let's go to 180 here, you can see that the image has been resized according to the size of the emulator that we're using. So we've got So we've got an image that's resizing appropriately, exactly for the size of the emulator. It's going to size appropriately when we pull it on a larger screen, on a smaller screen, and that's all being handled simply by placing the right size, the right resolution images inside of this this image resolution folder tree. So that's image scaling. Now let's look at responsive UI. How does our UI respond to these different resolutions, these different sizes of device? Well, it starts out with what we were talking about earlier, where the page is set up to make sure that whatever content you feed it will size itself to the space that we've got available to it. So the actual content area where we display our content is automatically adjusted to lie between the bottom of the status bar and the top of the app bar, and those bits of UI are visible. The page gives all that space to content, and your root content panel will fill all that space. So what are the factors that affect the XAML sizing? This is an example of kind of something you don't really want to do. Here we have explicitly set pretty much every element here. We've said that our margin is 6. It will always be 6. On a small device it's 6, on a huge device it's 6. The padding is always 12. The height is always 96. And so if we do that, this is not a very flexible XAML design, and it's not going to look good on every single device. Instead, we can do something, and this is where the grid layout really comes out to shine. Because the grid layout gives us this really fantastic way of doing proportional layouts with a couple of different ways of sizing things that work really well for responsive design. The first one is the star sizing, which I'm going to show before I jump into the other ones. Star sizing is proportional. And so if we have 1 star and 3 star, we add those two together, we get 4. So we get 1/4 and 3/4, 25% and 75% of whatever space is available. Auto sizing looks at the content that is inside of the grid row or column and says, I will give the items in there however much space they need to render. And then the proportional will split up the rest of the space however it can. We can give those auto spaces min or max widths and limits to their height. So we can say, for example, let's say we've got some text in there, and we put text into an auto row. Well, we can say, I don't want that to be any bigger than 100 pixels. At 100 pixels, you should stop giving it all the space it needs, and then let the proportional sizing, the star sizing, take over the rest of the space. The last one we can use is pixel sizing, which is a hard-coded size, which is something mentioned just before. Is we're going to want to avoid that in most cases because it's gonna look a little bit different on. It's less flexible and it's just going to look different on our different devices. So here's a nice simple example that I think shows how Grid allows us to do this great proportional layout. We've got a header. We've got a bulk items control, and then we've got a footer, so to speak. The header's in an auto area, in an auto portion of the grid. The footer's in an auto portion of the grid, and all the rest of the space belongs to this items control.
1 star, so we just get whatever is left. Yeah.
Yeah, whatever is left over belongs to that items control. So on our lower sized device, we can see that we have our 2.5 over and 3 down. That's all. Those are all the items we could fit in that space. But then we go to a larger size device and we get a lot more of those view pixels. And so in this case, we're actually looking at the items have been specifically sized. They're maybe 100 by 100 or 200. Yeah, maybe 100 by 100. That looks about right. But the header is still taking up the automatic space that it had available. The footer is taking up the automatic space it had available. We get more items in the space, both horizontally and vertically. So what should we put into that sort of additional space that we get with the proportional sizing? Well, there are a couple of really great things to put in there. The first one is, as we saw in the example before, the items control is a great thing to stick in there because then we can show more items on larger screens. The second one is text blocks and rich text blocks. So if we have a certain amount of text and we ended up having to cut that off because we just didn't have enough space on a 4-inch device, well, now we have a 6-inch device and we can show more of that text. We can give the person, the device with more space, more information. Anything that's going into a content or into a scroll viewer, When we put it into a smaller device, it's still visible with scrolling. A larger device, we can see more of it. We don't have to scroll as much. And then more complex controls like the map. When we put it in there, it'll resize to whatever space it can manage to get. And then it'll handle the rest of that resizing itself because it's awesome. The other option is if we don't want to try to do all that work, we can just scale the content as it's designed on one platform and put it in a viewbox control. So looking at some of the additional space content in a practical XAML, here we have some text in a lower sized device. You can see we've got the text wrapping, we've got some word ellipses, so whenever that text runs out of space, and in this case it has 20% of the screen space. Whenever that text runs out of space, it's just going to go to the ellipsis. On a larger screen, 20% of space means substantially more room for that text. We see we have more room to fit the text across the screen, we fit more words across the screen, and then we get an additional line stacking on top of the stacking in the text. If we want to put hard limits on that, we can always use something like max lines on our text blocks in order to say, 6 lines is enough for this piece of text. After that, we just don't need any more. Showing off the view box, this is an example. Let's say this is a control in there. This watch could be a vector graphic, or it could be a really complex XAML control that we've styled very carefully. And we realized that when we pull this XAML control into our Windows Phone application and we resize it, things get all wonky. Well, we can drop that inside the view box. The view box will render it in one size. And when we go to a bigger screen size, it will simply scale that entire control all the way up so that it looks better. Which
actually is what Windows Phone 8 did on all the devices. Effectively,
exactly.
Logically a view box,
right.
Which is how it got that kind of single layout sizing system that kind of worked.
Right, and so this is actually kind of neat because we can do this, but just on a case-by-case basis. Yeah. We can say, I want this control to render, to just simply size it up or down depending on how much space we have in the device. So, looking at the responsive UI in a demo form, pull up this responsive UI and I'm going to look at the. So here we have a view box holding this text. So this text will always take up. It will always be this big. The text will size to that area, and the view box will make sure that it resizes appropriately. It's sitting inside of a grid that has, let's see if I can, row definition, so 25% of the space up here at the top in the single star, and then 75% of the space in the bottom in the 3-star goes to this number grid that we have in place. So let's run this and see what this looks like. You see, so we've got that text up at the top, and we see that we have 4 items across, and then it scrolls down. We can change that by rotating, and now it looks like the text got bigger, and it did get bigger because now it has more space. It has more of the horizontal space it needs because it still has 25% of the space of the view that we have it in. You see, we have more of the items because they have not simply resized. They now have more space to make their layout. And so we lay out more across the side and fewer down because we have less vertical space.
The rotate animations come for free.
They do, and it's amazing.
Yeah.
So when we're responding to those rotation changes, we want to display dimensions that can change at runtime. We use that using the display information.get for current view, and then we just listen for the orientation changed event. And when it does that, we can handle that orientation change. This means that we can actually run what we saw before with the text and the items control. that was actually just the grid view, the grid panel being awesome, right? The grid panel and the view box working together to give us this great layout. Instead, but we can actually run code and change our actual layout if we use this orientation change, and that way we can change things like visual states. We can have one visual state that manages our screen when it's in portrait mode, and another visual state that manages the screen when it's in landscape mode. You see, in this example, what we have is an image inside of an auto grid and a text block inside of an auto grid, and we have a grid that is set up so that it works with both systems. It's a 2 across, 3 down, and we simply change the grid.row and the grid.column properties of our rich text block to move it from one place to another depending on which orientation we're in. So we're going to look at the orientation changes. And this one we're going to just open up the emulator, take a look at it, and then see how we've done that in the XAML. And here we have a single image, and if we rotate, we see we get kind of a much different layout. We still have the image there, but we've added a group of text on the orientation change. Okay, there we go.
Crazy.
We're going nuts. So the way we've done that is we have these visual state managers here. There is no way I just can't see this. We have these visual state managers, one for portrait and one for landscape. And when they come into play, we are changing the size of our image. We're changing the size of our image, and I think we're changing the visibility of our text information. And so if we go down, this is really big and I don't have a lot of space here. If we go down here, we can see that our text block, our image, we have our image, we have our text blocks here, and we are just going to hit those, we're going to change those visual states. The way we do that, as you saw in the slide deck, is we have that display information and we're listening for that info orientation change, that orientation changed event handler. And then when it hits, all we have to do is the visual state manager that we've defined. We say go to this one, go to landscape, go to portrait, and then it resets the properties on those elements, and we can go ahead and see them.
So you can hide elements. You can
hide elements.
Move elements from one cell to another in the grid.
Any property that we have on the element, we can change using our visual state manager. And so the last piece is for those edge cases where we really do need to know pixel information about the devices that we're on. The display information class gives us a lot of information. It gives us what our native orientation is, our current orientation. We can look at the raw pixels per view pixel, and this will give us the scale value. This is this is basically undoing the division that we saw earlier when we were taking. We are translating raw views into view pixels. This translates view pixels into raw pixels. We can use raw DPI X or raw DPI Y. There's not a whole lot of scenarios in which this makes a lot of sense, except for real object scenarios. And so we could take the raw DPI, do a little bit of math, and say, oh, well, you're looking for a 9-penny nail or a particular screw, and you could actually take a size on your device and say, I want an inch. Show me what an inch looks like on this device. The last one we have here is logical DPI. And the logical DPI is something we're going to want to avoid unless we're working in something like Direct2D that assumes the max DPI available is 96. And so it's something we just generally are going to want to avoid using. And back over to the demo. This demo is really very, very simple. It simply grabs all that information from the display information class and pushes it into our into some text that we have in our XAML. And so if we run that, we can run it on different devices, we can run it on different emulators, and we're going to see the specific information for that specific device show up here. So to summarize all of this information about adaptive UI, it really is a great deal of information, but it's important because we're now looking at an adaptive UI system that is shared between Windows and Windows Phone. This is beyond just uniform scaling of the UI. It's all about building a UI that just works for the device that we're on, for the orientation that we're in. We need to make sure that our display size of the runtime device, even though the display size is unknown at design time. The apps, this allows our apps to be responsive like they need to be. Our design for proportional layouts and not fixed sizes means that we can build applications that just fit all the devices orientations that we have in place. We can test this on different devices or more helpfully inside of our emulators. And we should consider using the techniques such as the Visual State Manager to handle all these changes and these different device sizes. Finally, that raw display information is available for those apps that need it, but we recommend to designers and developers to apply these adaptive UI techniques and make sure that you're not fussing over or worrying about the raw DPI or the raw pixels that you have available. So
good.
We'll be back in just a little bit.
Yeah, we'll take a few minutes, and then we're going to look at the life cycle and following that localization.